So let's do our first example. Let's say that I give you the function f of xy equals negative y. Okay? So, I mean, it looks a little bit silly because it doesn't depend on x, but that's not a problem. It's still a valid function of x and y. Just happens to be constant with respect to x. So to draw the graph, we look at the surface in space defined by z equals minus y. What kind of surface is that? It's a plane, okay? And if we want to draw it, z equals minus y, we'll look, well, that's the y-axis, that's the x-axis, that's the z-axis. If I look at what happens in the yz plane, in the plane of a blackboard, it will just look like a line that goes downward with slope 1. Okay, so it will do this. And what happens if I change x? Well, if I change x, nothing happens because x doesn't appear in this equation. So in fact, if instead of setting x equal to 0, I set x equal to 1, I'm in front of the blackboard, or minus 1 at the back, well, it still looks exactly the same. So I have this plane that actually contains the x-axis and slopes downwards with slope 1. It's kind of hard to draw. Now you see immediately what the big problem with graphs will be, that these pictures are hard to read. So that's our first graph. Okay, any questions so far? Okay, so let's say that we have a slightly more complicated function. How do we see it? So let's do another example. Let's say I give you f of xy equals 1 minus x squared minus y squared. So we should try to picture what the surface z equals 1 minus x squared minus y squared looks like. So how do we do that? Well, maybe you're actually very fast and you've already figured out what it looks like. But if not, then we need to work piece by piece. So maybe it will help if we understand first what it does in the plane of a blackboard. Okay? So if we look at it in the yz plane, that means we set x equal to 0. And then z becomes 1 minus y squared. What is that? It's a parabola pointing downward and starting at 1. Okay? So we should draw maybe this downward parabola. It starts at 1 and it cuts the y-axis at 1. Okay? When y is 1, that gives us 0. What do we see? So we might have an idea of what it might look like, or maybe not. Let's get more slices. Let's see what it does in the xz plane, this other vertical plane that's coming toward us. So in the xz plane, since we set y equal to 0, and we get z equals 1 minus x squared, it's again a parabola coming downward. Okay, so I'm going to try to draw a parabola that goes downward, but now to the front and to the back. So we are starting to have a slightly better idea, but we still don't know whether the cross-section of this thing might be, round, square, something else. So if we want more confirmation, we might want to also figure out maybe where does this surface intersect the xy plane. So we hit the xy plane when z equals 0. That means 1 minus x squared minus y squared should be 0. That becomes x squared plus y squared equals 1. That is a circle of radius 1. Okay, that's the unit circle. So that means that here we actually have the unit circle. And now you should imagine that you have this thing that, when you slice it by a vertical plane, looks like a downward parabola, and it's actually a surface of revolution. You can rotate it around the z-axis. Okay? Now, if you stare long enough at that equation, you'll actually see that, yes, actually, a posteriori, we know that it had to be like that. But, see, so these are useful ways of trying to guess what the graph looks like. Of course, the other way is to just ask your computer to do it, and then, you'll get that kind of formula. Okay. Well, I can leave it on if you want. But no, because I plotted a different function that I will show you later. So it goes this way. If you want 1 minus, it's really going downward. Yes, I agree that the sheet is upside down, but that's because I plotted something else. Okay. So, in fact, so what I plotted in my computer was actually x squared plus y squared. That looks like that. See, it's the same with a parabola going upwards. If you want to see more examples, I have various examples to show. Well, here's the graph of a function y squared minus x squared. See, so that one is kind of interesting. It looks like a saddle. If you look at it in the yz plane, then it's a parabola going up, z equals y squared. And that's what we see to the left and to the right. But if you put it in the xz plane, then it's a parabola going downwards, z equals minus x squared. So we have a parabola going downwards in one direction, upwards in the other one, and together they form this surface. And of course, you can plot, much more complicated functions. So this one, if you can read very small things, then you can see the formula, but it doesn't matter. Just to show you that, you can put the formula into a computer, and it will show you a picture. Okay. So that's pretty good, but you can see that it can get a bit cluttered, because maybe there's features that are hidden behind, or maybe we have trouble seeing. If we don't have a computer, that looks very readable, but this is kind of hard to visualize sometimes. So there's another way to plot functions of two variables, and that's called the contour plot.